Hey folks, welcome back to the channel. Today we will be covering the problem minimizing points. The problem is pretty straightforward and pretty similar to dice combinations if you look carefully. We have been given n points. Each coin will have a positive integer value. We have to obtain a sum of it using the available points, but we have to keep in mind that we use the minimal number of points possible. Now, how is this problem similar to dice combinations? There we have to roll a dice and obtain a sum. Let's open the problem in another page and so that you can see. So here we had to obtain a sum n by rolling it and the values which we could get were between 1 and 6. Now assume for a second that you have coins of value 1, 2, 3, 4, 5, and 6. Then the solution of this problem would be pretty similar to the one here. So if you can solve, say, minimizing points and the points value is 1, 2, 3, 4, 5, 6, you could solve dice combinations as well and vice versa. So we look at the solution and then we'll compare the similarities of it. So here is the solution. We have been given an array of points C1, C2, C3 up to Cn. We have to obtain the number x. Here are the constraints. Now, each coin can be used infinite number of times. That is, there is no such limit on the usage of a coin. If you use C1, for example, you can use C1 again. Now, how can you reach this number X? Well, just like in dice combinations, suppose you got C1. Now, if you know how to get X minus C1, the problem is similarly, if you get C2 and know how to get X minus C2, the problem is solved again. Similarly, for the case X minus Cn. And in general, we can say this. If you know how to get X minus Ci, you can just add Ci to it and you have the problem solved. Now let's see how we'll structure the solution. Initially, we'll assign the answer of X to be infinite because we want to find the minimum number of points. And then answer of X can be minimum of answer of X minus Ci plus 1. Plus 1 because you are adding the Ci point to the answer. What will be the base case? Well, to obtain a sum of 0, you need 0 points. So the base case will be that answer of 0 is 0. Do check and compare the solution of dice combinations with this problem and you'll realize this how similar they are. One more interesting caveat. The value of infinity, mostly we naively initialize to something really big, but make a habit of knowing the upper bound of your solution. It comes in handy at many places. So in this case, constraints are that x can be between 1 to 10 to the 6. So the maximum value of x is 10 to the 6. And CIs are between 1 and 10 to the 6 as well. So minimum value of CI is 1. That means consider a question or a test case where x is 10 to the 6 and all of the CIs are given 1. Then you will need 10 to the 6 amount of points. So infinity can be 10 to the 6 plus 1. This is a strict upper bound to our solution as our answer will always be less than infinity. That is 10 to the 6 plus 1. Let's move on to the code. So here's the code. It's pretty similar to what we discussed on the previous page, which was the time taken solution. We initialize infinity to 10 to the 6 plus 1 since it's strict upper bound to the possible values of valid solutions that we can make. We initialize every element of dp to infinity and the base case, which is to get 0 as the amount, we initialize the number of points needed in that case to 0. Then we use the outer loop to iterate over the values which we want to obtain. And this inner loop is used to iterate over the point values which we have. In case the value which we are trying to obtain is greater than or equal to CR, we can update the answer accordingly. And finally, while printing the solution, we check if the dp of x, the value which we got, is not equal to infinity, or is it that it's equal to infinity. If it's not equal to infinity, we can be sure that we have obtained a valid solution. However, if it is equal to infinity, then we can claim that there was no way to actually obtain this sum by the given set of points. Let's now submit the solution. It's great. Yeah, it gets accepted. So to check the codes and compare it with the code we used to solve dice combinations and see just how similar they are. That way you'll see that this is a general idea. You can sort of club similar problems. So thank you for watching. Like, share, and subscribe. And see you next.